everyone. Welcome to Mathfinity, where math learning is fun and exciting. For this video lesson, we will be guided by the Most Essential Learning Competency 4 and 5. Those are illustrates geometric sequence and differentiates geometric from an arithmetic sequence. At the end of this video tutorial, you will be able to identify geometric sequence correctly. Secondly, you will be able to differentiate geometric from arithmetic sequence. And lastly, you will be able to solve for the common ratio of geometric sequence. To continue this tutorial, let's define what is geometric sequence. Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio.
Let's try to verify if the sequence 1, 2, 4, 8, 16 exhibits geometric sequence. Remember, the definition of geometric sequence is it is a sequence whose terms after the first is obtained by multiplying a constant number that is called the common ratio. If we are going to write the terms recursively starting from the first term, we will arrive at this, letting a sub 1 be equal to 1. Second term is written as the previous term of the second term multiplied by a constant number, and that should yield the value of the second term 2. Now, what must be multiplied by 1 in able to arrive at the value of 2? That should be 2. Because 2 divided by 1 is 2. That implies 1 times 2 is equal to 2. We multiply the previous term 1 by 2 to arrive the second term, which is 2. Enable for us to identify the value of the third term, we will use again the previous term, that is 2 multiplied by a certain number to arrive at the third term, which is 4. What must be multiplied by the previous term 2 in able to get the third term 4? That must be 2 as well, because 2 times 2 is equal to 4. In able to get fourth term, we will use the previous term 4 that is to be multiplied by a certain number that should be arriving at the fourth term, which is 8. What must be multiplied to 4 in able to get 8? That is 2 as well. 4 times 2 is equal to 8. And we define fifth term as the previous term 8 multiplied by a certain number that is to arrive at the fifth term, which is 16. What must be multiplied to 8 to get 16? That is 2 as well. If you're going to take the ratio of two consecutive terms, any two consecutive terms, you will notice that the ratio remains constant. For example, the second term 2 divided by the first term 1 is 2. It implies the ratio of the second term to the first term is 2, because 2 divided by 1 is 2. Another is, if you take the ratio of the third term 4 and its previous term 2, you will arrive at the ratio of 2. Another, if you take the ratio of the fourth term 8 and its previous term 4, the ratio remains 2. And lastly, if you take the ratio of the fifth term, which is 16, and its previous term, which is 8, the ratio remains 2. Therefore, the ratio of two consecutive terms in a geometric sequence remains constant. And that is what you call the common ratio. By definition, common ratio is written as or is equal to a sub n divided by a sub n minus 1. A sub n represents the n term, that is any term in the sequence, and a sub n minus 1 is representing the previous term. To show that the ratio in this sequence remains constant through this formula, let's try substituting some of its values. Common ratio is equal to a sub n over a sub n minus 1. If I try to use the fifth term, which is 16, so that will become a sub 5 divided by a sub 4, because the previous term of a sub 5 is a sub 4. So that's how you will write common ratio. That is the same as the ratio of the fourth term to the third term. This ratio is the same as the ratio of the third term to its previous term, which is a sub 2. And that should be equal as a sub 2, that should be equal to the ratio of a sub 2 and a sub 1. By substituting their values, a sub 5 is 16, a sub 4 is 8, a sub 4 is 8, a sub 3 is 4, a sub 3 is 4, a sub 2 is 2, and lastly, a sub 2 is 2, a sub 1 is 1. If you simplify this equation, 16 divided by 8 is 2, 8 divided by 4 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2. The ratio of geometric sequence remains constant in any two consecutive terms, that is a sub n divided by a sub n minus 1. So we have verified already that the sequence 1, 2, 4, 8, 16 is geometric. Let's try to consider another example. Example number 2, the given sequence is 3, 8, 13, 23, and so on. We will verify or we will determine if this sequence demonstrates geometric sequence. Again, enable for us to verify that a sequence is geometric, there should be or there should exist common ratio in the sequence. So let's try to verify whether the sequence is geometric by determining whether common ratio exists. The first term is 3, second term is 8, third term is 13, and fourth term is 23, and so on. Let's determine or let's try to verify whether there is a common ratio. common ratio is defined as a sub n divided by a sub n minus 1. Any term divided by its previous term. So let's try to use the second term and the first term. So let's represent the first ratio or the ratio of the second term to the first term as r sub 1. So that will be second term divided by the first term. The second term is equal to 8. The first term is equal to 3. So that is substituted as 8 divided by 3. 8 and 3 do not have common factor, so it's already simplified as 8 thirds. So the ratio of the second term to the first term is 8 thirds. Let's try to determine whether the third term and the second term has the same ratio as 8 thirds. The third term divided by the second term, by substitution, the third term is 13 and the second term is 8. Third term, the ratio of the third term and the second term is 13 over 8, because 13 and 8 do not have common factor enable for this to be simplified. Therefore, the ratio of the third term to the second term is 13 over 8. So as you will notice, r sub 1 and r sub 2 are not the same. So clearly, we can tell that this sequence is not geometric. So as you can see, the sequence 3, 8, 13, 23 seems to have a common difference in any consecutive terms. Let's try to verify. Remember, common difference exists in arithmetic sequence. Let's try to verify that this sequence is arithmetic. Remember, common difference is a sub n minus a sub n minus 1, or any term minus its previous term. So let's try to use the difference between the second and the first term. So a sub 2 minus a sub 1. A sub 2 is 8. A sub 1 is 3. 8 minus 3 is 5. Let's try to verify that we have the same difference as the third term and the second term. That's d sub 2. So a sub 3 minus its previous term, which is second term. So that is, third term is 13. Previous term of the 13 is 8. 13 minus 8 is 5 as well. And you will notice that the difference of the fourth term and the third term as well is 5. Therefore, in this sequence, there exists a common difference. It is not geometric, but it is arithmetic. We have identified that the sequence 3, 8, 13, 23 is not geometric, but it is an arithmetic sequence. Let's try to consider illustrative example number 3. The sequence is negative 20, 10, negative 5. Again, we need to verify that this sequence has a common ratio. In able to determine that, we need to use the formula R is equal to a sub n divided by a sub n minus 1, or n term divide its previous term. So let's try to verify that in this sequence, there exists common ratio. So let's try to identify the ratio of the second term to its first term, or to the previous term, which is first term. And let's define that as r sub 1. That is a sub 2 divided by a sub 1. A sub 2 by substitution, that is 10, divided by a sub 1, which is negative 20. 10 divided by negative 20 is the same as, when evaluated, that's negative 1/2. The ratio of the second term and the first term is negative 1/2. Let's try to determine whether the third term and the second term has the same ratio as negative 1/2. So that is third term divided by the second term. By substitution, that the third term is negative 5, the second term is 10. So that is negative 5 over 10 when simplified, that's the same as negative 1/2. We can clearly say that r sub 1 and r sub 2 have the same value as negative 1/2. Therefore, there exists common ratio of negative 1/2. Therefore, it is geometric sequence.
Let's now try answering the following exercises. Determine whether the sequence is arithmetic, geometric, or neither. Remember, a sequence is said to be arithmetic if the sequence has common difference, while a sequence is said to be geometric when the sequence has common ratio. If the sequence does not have common difference nor common ratio, then it is neither arithmetic nor geometric. You can pause this video and able for you to answer this at your own pace.
Let's now check whether your answers are correct. Number 1, the given sequence is 11, 14, 17, 20, and so on. In this number, let's try to verify whether it is arithmetic or geometric. Let's try to verify whether it is arithmetic sequence. If it is arithmetic sequence, then it should have common difference. Let's try to verify whether it has a common difference. Let's try to determine the difference between the second term and its previous term, which is first term. 14 minus 11 is equal to 3. The difference between the second term and the first term is 3. Let's try to verify that the difference between the third term and the second term is the same as 3. 17 minus 14 is 3 as well. Let's try to determine whether that is the same difference as the fourth term and the third term. 20 minus 17, that is 3. As you can clearly see, the difference between any two consecutive terms of the sequence 11, 14, 17, 20 is 3. Therefore, it is arithmetic. Let's proceed to number 2. Number 2, the sequence is 4, 8, 16, 32, and so on. let's try to determine whether it is arithmetic first. If it is arithmetic, there should be a common difference. Let's try to find what's the difference between the second term and the first term. That is 8 minus 4. That is 4. Another, let's try to determine that the second difference, or the difference between the third term and the second term, is the same as 8. 16 minus 8 is 8. So, based on this, based on the first two difference of two pairs of consecutive terms, we can conclude that this is not arithmetic. Let's try whether it is geometric. Let's try to verify if the sequence demonstrate geometric sequence. Remember, geometric sequence has a common ratio. So let's try to determine the ratio of the second term and the first term. And let's define that as r sub 1. That is second term, which is 8, divided by 4, which is the first term. 8 divided by 4 is 2. Next, r sub 2 is 16 divided by 8, that is 2 as well. R sub 3, that is the ratio of the fourth term and the third term. That's 32 divided by 16, that is the same as 2. Therefore, r sub 1, r sub 2, r sub 3, or since the value of r sub 1, r sub 2, r sub 3 are the same, therefore, it has a common ratio. Therefore, it is geometric. Let's continue answering number 3 and 4. Let's try verifying whether the sequence has common difference. Let's try to identify what's the difference between the second term and the first term. So 8 minus 5 is equal to 3. Let's try to determine whether the difference between the third term and the second term is the same as 3. It's a second difference. So that is 12 minus 8 is equal to 4. As you can see, the difference between the second and the first term is 3. The difference between the third term and the second term is 4, and they are not equal. Therefore, it is not arithmetic. Let's try to determine whether it has common ratio. Let's try to solve for the ratio of the second term and the first term. The second term is 8. The first term is 5. So, since 8 and 5 do not have common factor, the ratio is 8/5. We cannot simplify that anymore. Let's proceed to the ratio of the third term and the second term. That's r sub 2. So 12 divided by 8 is the same as, or simplified as, 3/2. The greatest common factor is 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So the ratio is 3/2. So you can clearly see that 8/5 is not the same as 3/2. Therefore, this ratio or this sequence does not have common difference nor common ratio. So this is not geometric. The answer is neither arithmetic nor geometric. Number 4. We need to find again the common difference and the common ratio. So, let's try verifying whether the sequence is arithmetic by finding the common difference. And let's try to verify, or let's try to determine the difference between the second term and the first term. It's 28 minus 32, that is equal to negative 4. Let's try to determine whether the third term and the second term has the same difference as negative 4. That's 24 minus 28 is equal to negative 4 as well. Let's continue verifying whether it has common difference by using or by finding the difference between the fourth term and the third term. The fourth term is 20. The third term is 24. 20 minus 24 is negative 4. Therefore, in any consecutive terms in the sequence 32, 28, 24, 20, they have common difference of negative 4. Since it has a common difference of negative 4, it is arithmetic. Is that clear? Last, number 5. Let's try to verify if it has common difference. Again, let's try to determine the difference between the second term and the first term. That is 8 minus 1. Second term minus first term, that is 7. Let's proceed to the difference between the third term and the second term. Third term is 27 minus its previous, which is 8. 27 minus 8 is 19. So based on the difference of two pairs of consecutive terms, we can tell that this is not arithmetic because they don't have common difference. Let's try to verify if it is geometric. If it's geometric, it should have common ratio. Let's try to find the ratio of the second term and the first term. And let that be r sub 1. Second term is 8 divided by the first term, which is 1. 8 divided by 1, that is 8. So the first ratio is 8. Let's try to determine the ratio of the third term and the second term, and let that be r sub 2. 27 divided by 8, since they don't have common factor, the answer is 27 over 8. The ratio is 27 over 8. So as you can see, the sequence does not have common ratio as well, because the first ratio is 8 and the second ratio is 27 over 8. Therefore, we don't have common ratio. This is not geometric. So since it is not arithmetic nor geometric, our answer is neither.
I hope you learned something from this video. Again, this is Sir JC reminding you, math is easy when you perceive it positively.